Okay, using the cosine rule to find an angle. Okay, so example 1. Find angle theta, correct to 1 decimal place. Here's a triangle. We know one side is 6, one side is 3, and one side is 4. And theta is here, between the 6 and the 4. And our job is to find out what theta is. Please note that Pythagoras' theorem wouldn't work here. Well, Pythagoras' theorem can't even find an angle anyhow. SOHCAHTOA won't work either because it's not a right angle triangle. Okay, the sine rule won't work either because for a sine rule to work we would need a pair, which we have here, but we need another pair. And the problem is 4, we don't know the angle across from it, and 6, we don't know the angle across from it, so we don't have a second pair. The cosine rule will work because we've all 3 sides, and once you know all 3 sides of a triangle, you can always use the cosine rule to work out any angle you like. So I'm going to write down the version of the cosine rule that's in your maths tables. A squared equals b squared plus c squared minus 2bc cos a. That's the cosine rule. And what I'm going to do is, the most important thing is when you're trying to get an angle, the most important thing is wherever your angle is that you want to find. So in this case, I'm going to highlight it in blue. This is my angle theta. Then the side across from it, which is 3 in this case, that must be our little a. So that would be a, and theta would be big A. And then B and C don't really matter too much, but B should be 6 and C should be 4 or vice versa. But the most important thing is to get your A's, the start and the end, correct. And that's your pair that match. And once you have that down, it's very easy. What I'm going to do is instead of A squared, I'm going to have 3 squared equals. Instead of B squared, I'm going to put 6 squared. So I'm going to call B, just so we can see, B is 6 and C is 4. But the most important ones are your A's, okay? So 6 squared plus C squared will be 4 squared minus 2 times my B number, which is 6, times my C number, which is 4, times the cosine of theta. Now you'll see that that's where the letter is now. Now, unlike the previous examples where we found out the length of a side, we cannot type this whole thing into our calculator. And the reason we can't type the whole thing into our calculator is we don't know what theta is. However, we can do bits and pieces. So for example, 3 squared, you can do it on your calculator if you don't know, it's 9. 6 squared is 36. 4 squared is 16. And for this bit here, be very, very, very careful. Be careful, it's a minus 2 by a 6 by a 4. Ignore the cos theta for a second. What's minus 2 multiplied by 6 multiplied by 4? And when you're multiplying these out, students often leave out the minus, and that is a mistake. So minus 2 by 6 by 4. If you want to do it on a calculator, put minus 2 by 6 by 4. It's going to be a minus answer. And 2 6s are 12 and 12 4s are 48. So it's minus 48 cos theta. Now what we do next is, I want to get this cos theta, the minus 48 cos theta, over to the left-hand side. So I'm going to bring this whole minus 48 cos theta over to the left-hand side of my equals. And to do that, I just bring it over and change it to a plus 48 cos theta. So I'm going to have 48 cos theta is equal to the 36 plus the 16 that were already on the right. And at the same time, I'm going to get this 9 and bring it over to the right. So when you bring the 9 over to the right, it becomes a minus 9. So what I've done here is I've brought the minus 48 over to the left, and at the same time I got the 9 and I brought that over to the right. Okay, so I get 48 cos theta is 36 plus 16 minus 9. Now the right hand side can be put into the calculator. We can go 36 plus 16 minus 9 and press equals, and it's 43. So I'm going to rewrite this as 48 cos theta is equal to 43. Now, the next step is I want to get cos theta on its own. And how I get cos theta on its own is the 48 is being multiplied by cos. That's what 48 cos means. It means 48 multiplied by cos theta. To get rid of a multiply by 48, we divide. So look, it's 43 over 48. And we've seen this kind of thing before where you have cosine or sine or tan is equal to a fraction. And how do we get theta on its own? Well, to get theta on its own, we do inverse cos of 43 over 48. And the good news is all we have to do is type this into our calculator. So I'm going to press Shift cos, fraction key, 43 on top over a 48 on the bottom, arrow out, close my bracket, and press equals, and up comes my answer. Now we want to correct to 1 decimal place in this question, so it's going to be 26.4 degrees. So 26.4 degrees is my answer for example 1. So as you can see, to work out an angle with the cosine rule, it's a little bit more tricky than working out a side. You have to move things around before you can use your calculator. Let's do a second example. Example 2, we have to find angle B to the nearest degree. Again, look, the most important thing is, because we're looking for angle B, across from that is the thing that's going to match it. Now, usually if that's big B, we'd call this little b. But if you want to use A's, you can rebrand this temporarily as your A, and this is your little a. Okay, I'll get to that in a second. But there's a pair. Notice the sine rule won't work because we don't know any other pairs. So let's use the cosine rule. So if you want to use the version in your maths tables, a squared equals b squared plus c squared minus 2bc cos a. I know this is written as a b and that should be a little b, but you can rechristen it in your own head as a's. So in other words, the most important thing is the start of your cosine rule and the end. They must be your pair. So here's our pair in this case. So if you wanted to, you could rechristen this as little a and this big A, but don't write it as a big A in your answer. It's b. Okay, that's the confusing thing that students get confused about. Okay, so a squared is the side squared, so it's 3 squared equals my other side, I'm going to call it 6.5 to be squared, plus my other side, which is 7 to be squared, minus 2 times 6.5 by 7 times the cosine of this angle here, which we're going to call b. So you'll notice that once you've subbed in the numbers, you don't have to worry about labeling. So, you know, the main thing is the pair here have to be at the start and at the end. And then the other two sides here and here are your B's and C's. Okay, that's the most important thing. So let's see. Let's multiply everything out with our calculator. 3 squared is 9. 6.5 squared, I have to use a calculator. 6.5 squared would be, I'm going to write it as a decimal, 42.25. 42.25 plus 7 squared is 49. And don't round off decimals until the very end. And then look, minus 2, I'm going to go minus 2 on my calculator, bracket 6.5, close bracket, bracket 7. Make sure to include the minus. If you leave out the minus in this, you're going to get things wrong. And this is minus 91 cos B. Okay, now, a bit like the last question, I'm going to drag this minus 91 cos B over to the left, and that becomes a 91 cos B. And I'm going to leave my 42.25 and my 49 on the right. And at the same time, I'm going to bring my 9 over to join them. So it's minus 9. So now I get 91 cos B is equal to, and I have to add and subtract these numbers on the right. So it's 42.25 plus 49 minus 9 equals, and I'm going to write it as a decimal. It's 82.25. 82.25. Okay, we're getting close to the end here. The last thing I want to do is get cos B on its own first by dividing by 91. So it's 82.25 over 91. You can work that out if you want as a decimal and leave lots of decimals, or leave it like this for now. And then B is cos inverse of 82.25 over 91. And all I have to do is type that into my calculator and I'm finished. So I'm going to go shift cos fraction key 82.25 over 91, arrow out, close my bracket, and press equals, and up comes 25.33. So 25.3, actually to the nearest degree. So 25.33, I'm going to write 25.33 degrees, and then on my answer, I'm going to round it to the nearest whole number, nearest degree, which is 25 degrees. And that there is another example of using the cosine rule to find out an angle. So there are some examples in your book that you can use to practice this.